and that will help you to find out what do you mean by polar. Okay, it's not a polar bear, right? Something else in the chemistry. And why something dissolves on certain things or not. That helps you. It's again about electrons. It's a very powerful, the tiny many things. Now remember when you do the Lewis, CO2, this is what we end up with. CO2. Okay. Now what does that mean? These electrons, so carbon and oxygen, so now these electrons are here. Now let's find out whether they stay in between or they are lenient to move towards one or other. Okay, just like this. Okay, if looks like can you hold this? Hold this right here. This looks like, let's say there are two electrons. Okay, from there you are seeing that they are right in the center. Okay, nobody is pulling. Okay, can you pull a little bit? Pull, see. But inside we are like, okay, I'm pulling. C is pulling too. Okay, these electrons are pulling towards one partner. So let's find out which are more energy, which is more strong, because either C is stronger than me or other way. Same thing when you have two partners, not necessarily they have equal energy. One has more tendency to pull those electrons towards itself. So, thank you. Now here, in C and O, look at here, C here and O here. The rule is, the tendency is moving towards, increases this way. This is called electronegativity. Means the tendency to attract this bonded electron towards itself. That's the way that she is putting towards herself and I'm putting myself. So this is electronegativity. This is know that electronegativity here. Electronegativity. It is tendency to attract the bonded electron towards one partner. So there is a tendency to attack the bonded electrons towards one partner of the bond. And then it increases from left to the right. So increases from left to the right, this way. So remember carbon oxygen, so oxygen has more electron than carbon. That means the tendency is, this bonded electron has a tendency to move this way. The tendency to move this way. Okay, they are not right in the center. Okay, so that means if they move this way here, it has more electrons, slightly more electron density. The lobe is towards, the house is bended towards this. So it is slightly negative. It's the same thing, slightly negative and slightly positive. Okay, because proton is here, not the proton and electron, they have fixed distance, right? But because of this, the electron moves towards oxygen. And the proton in the neutral carbon, and proton here in CO2. Now here, CO2, the proton here in CO2, carbon of CO2, has electron a little farther from the neutral carbon. So that's how, in that sense, we say slightly minus, slightly minus, slightly plus. So that means here slightly minus and slightly plus. It is a polar. This is a bond. This bond is polar bond. Between fluorine and fluorine here, they are equal distance. This is a pure polar. Pure covalent, no polar. Pure covalent. You don't have delta minus, delta plus here, no. All of them by diatomic molecules, they are a pure covalent. This is polar covalent. This is covalent because non-metal bonding. But it is a polar covalent, which has two poles, positive pole and negative pole. Slightly positive and slightly negative. Not like a regular fully positive and fully negative in alkyl. So this is a polar bond. This is a polar. Now, in your water also, which has more tendency, as I know, oxygen has more electronegativity here. So this is bonded electron has a tendency to move this way, has a tendency to move this way. At some point here, they go together. Have more density, they meet. So that means it is slightly plus, slightly plus, slightly minus, minus, minus. So that means here they meet. These electrons, when they have a tendency, they meet here. They strengthen the negative force here. But here, these electrons, they move this way. They have a tendency to move one way, another way. The bond is here. The whole molecule is non-polar molecule. Here, this water is a polar molecule because of the shape. The molecular polarity depends on the shape. There is a bend shape. This is a linear shape. If the molecule is linear, the molecule is non-polar. If the molecule is bent, then it is a molecule polar. Okay? Go ahead.
So any 3D shape would be polar?
Say again?
So any 3D shape would be polar?
Very good questions. So let's find out. If they have a charged molecule, like a sodium ion or chloride ion, anything, they are polar. Okay? If they have a lone pair in the center, like ammonia, we did that. Because of the lone pair, it is a polar. Okay? Now it's a tetrahedral. If the tetrahedral, it is a non-polar because of different atoms. Okay? And then if it is tetrahedral with the lone pair now, this is a tetrahedral with the lone pair, it is a polar. Ammonia, tetrahedral with lone pair, is a polar.
So anything with the lone pair is polar?
Yes, anything with the lone pair polar, anything with the charge in central atom polar, okay? BF3, they never meet. Listen here, BF3, non-polar. Planar, non-polar. Very good questions, good job. See here, BF3, this is never going to meet. This is never going to meet. So the molecule is non-polar. So that's why the carbon dioxide is very hard to dissolve in water. Sodium chloride dissolves in water. Sodium chloride is polar, positive and negative charge. Water, slightly positive, slightly negative. So that's why they dissolve. Like dissolves like. Polar compound dissolves in polar compound. Now carbon dioxide is non-polar. It's not going to dissolve in water, but slightly dissolve because they have a bond polarity. Over the time, their solubility increases because of bond polarity. But if you put the fluorine here, fluorine in water is not dissolved. There is no bond polarity to it. That's the matter. Okay? Okay. I'm going to give you some tips. There's a lot of information, so go home and recall those informations. But you may expect some questions. What is bond polarity? What is electronegativity? Which molecule is polar? Which is not polar? You know? Yeah. Fat. Fat is non-polar because it doesn't have a charge. But it's slightly polar, like cholesterol, slightly polar because of bone polarity. Molecule is not polar, but bone polarity. If we have to dissolve the molecule with only bond polarity, means only made by only with two different atoms, it takes a long time to break or to dissolve. That's why fat molecules, we really need to work out to split the fat molecules or to split the cholesterol molecule because they are not polar. They just have they're slightly dissolved, but because of just the bone polarity, but not the molecular polarity. Okay, so that's why these cholesterol molecules, fat molecules, is very hard to dissolve. But if you do the sodium chloride, it easily dissolves because of the polarity. So we wish this cholesterol and things like that could be polar, so we don't have to work out and we don't have to exercise. But it doesn't work that way. Okay? All right, I'm going to stop that part. Let's move on to the last one. So it's going to be short, okay? So if you know chemistry, you will be fully motivated about the diet, about the nutrition. You can choose your food items, yourself, and at least you understand it. Maybe even if you don't, your tongue doesn't help you because you like the tasty foods, but chemically you can figure it out what went wrong, what you need to eat, what you don't want to eat, things like that. Again, it's a biochemistry is more juicy. You can add the juice of biochemistry over the chemistry, it makes you more relevant. Okay? All right, let me move on to the gas. Everybody know gas is state of matter. Okay? But let me ask you this. When you talk about the gas, this gas, we say empty, but it has a gas. Okay? We say empty because it has a gas, 99.99% empty. Whenever you have a gas, the container is, we say empty because 99.99% is empty. 0.01% gas is. Okay? Now, one property of gas, we will talk about it in the experiment. What is the volume of the gas in this container? Volume of the gas. All of it. Volume of the container is the volume of the gas. Remember the other day? You boil it, you evaporate it, you change to gas, and the volume of the gas is over. So, the one thing, make sure you know that volume of the gas is volume. How about the sip? Now this is the same gas here. You pour that gas on this one, it takes the shape of the container. So volume and the shape of the gas is volume and the shape of the container. That's the one. Now that it's compressible, remember you use the piston? Piston. You can compress it. The water compressible? Know that water has water. So what is common with the water? Liquid. One common is both of them take the shape of the container. Gas and water. Sorry, gas and liquid. But water cannot be compressed. Gas can compress. And gas volume is the volume of the container, or water. Okay. These are the few properties of gases. They are easy, but you need to realize them. Now, there are some gas laws. So the first one is a Boyle's law. I'm going to just write the mathematical aspect. So the volume is directly proportional to the pressure. That means the piston, you increase the pressure, volume decreases of the gas. If you release the piston, means decrease the pressures, volume increases. Okay? Volume and pressures, they are related that. Now volume and temperatures, temperature increases, volume increases. Just like this. Let's say you have a balloon here. One balloon. If you put in a boil water, you're going to have a bigger volume. Or if you put in ice water, your volume is going to be like this. So here, the same balloon, here, if we keep boiling it, at some point it will burst. It bursts. Because this volume is increases, as they space around, and it bursts. Okay? Here, if you have ice, the temperature decreases, so it sinks, volume decreases. So volume and temperature are directly related. Temperature increases, volume of the gas increases, vice versa. Okay? Now another is, volume is directly proportional to the N. You know what that N means? Avogadro's number, right? That is number of moles. Okay? That means volume increases if you blow, let's say a balloon here, assume a balloon. If you blow a low, less amount of air, little bit, you get a small balloon, right? If you pass a lot of air, the balloon is going to be bigger size. See that? So in the first one, you have less number of moles of gas, small balloon. Next one, you got a more moles of gas, you got a big balloon. Okay? So volume is directly proportional to the number of moles of gas. Okay? Now you put all this together, so V is directly proportional to, so you have N, you have T, you have P. all go together. This is the sign of proportionality. You can change the sign of equality with some kind of constant. From the math, so you have this one side. You have R and T over P. So R is a gas constant. Now, a lot of times in your math, sign of proportionality change the sign of equality to some kind of constant. What is constant? Why you put constant? What that mean? I know there is a practice, but what exactly that means? Let me give you an analogy. Let's say there is an alien. He came to the earth and find out, oh, there are human beings. They all have one nose, 2 eyes, head, mouth, body parts. Okay? We all have. Those are the common. Constant means common. Then after that we have some variability. Some of us have longer nose, others have shorter nose. Some of us have thicker nose, and others have skinny nose. Things like that. So we have some commons. Then within the commons, after that, to find the personality, you come up with different variability. So that's the constant. Commons. You remember that one. So that means all the gas, when you do it, they have some common properties, like your volume, like your shape, right? Compressibility, they are common properties. That includes within that R. And then we can deal with individual properties to come up with individual personality of a gas. Okay? So, now if we put this is a gas constant, and this value is a constant value, 0.08, 206. Now we have one unit, I'm going to explain that, okay? Liter, atmosphere, per mole, per degree Kelvin, or sometimes it is written like liter, atmosphere, per mole, per degree Kelvin. Sometimes it is written like liter, atmosphere, per mole, per degree Kelvin. One sentence. Because these units at the bottom go to the top with a change in sign. Because the power is positive, go up with the negative power. Okay? So, now we can write this in one sentence, PV equals to nRT. PV equals to nRT. I just cross multiply that. PV equals to nRT. Now, if you put the R here alone, PV over NT is R. See that? If you put all these units, pressure is in atmosphere, volume in liter, N is mole, temperature is degree Kelvin. See, I put all of them, I end up with this unit, liter, atmosphere, per mole, per degree. You don't need to memorize the unit. Memorize. As long as once you come up with all these rules together, then make sure these are the units you have to. That means when you do this problem, you'll face some problem in the exams and do some practice in your top hat. So this is anything the pressure you change the atmosphere all the time. Pressure has some units. This is a torr unit, and this is atmosphere unit, this is a PSI unit, and there's a Pascal unit. But more commonly we use in our chemistry torr and atmosphere. So 760, the conversion factor is 760 torr. You need to remember this, 1 atmosphere. Okay, know that. So, you convert, if there is a torr, convert to the atmosphere, making two relations, 760 torr over 1 atmosphere or 1 atmosphere over 760 torr. If the torr is given, if sometimes the 50 torr is given, torr cancel out, convert to the atmosphere, we get out at 8.97 atmosphere left. Okay, so make sure, the whole thing is, when you do this calculation, change that torr to the atmosphere. Make sure know that, don't forget. Liter, volume collections, if there is a milliliter, change to the liter. Torr, change to the atmosphere. Mole, if there is a mass, change to the mole. If it's a degree Celsius, change to degree Celsius, change to degree Kelvin. By adding 272. Okay? That's pretty much you have to be careful when you handle this kind of equations. Also, what is the application? This is called ideal gas equation, PV&RT. It has the applications. Now, when you talk about the applications, PV, this can be rewrite, number of moles means mass over molar mass. RT. You can make one line here, cross multiplications. I did that, cross multiply. So molar mass is mRT over dV. So that means, let's say you assume, okay, you calculate all this value and you end up with 40 molar mass. So if you look at the 40 molar mass, oh, argon, 39.98. So then you can say, oh, I have argon. I identify this argon. So looking at this value and looking at the table, you can find out which gas you are talking about in the calculations. So you can find out the identity. The other one you can find out here, this can be rewrite here. PV equals to mass over molar mass. RT, then you can also have P molar mass M by V RT. Can you see that? I did the cross multiplications here, and then M and V goes down. So you can write this P M by V is mass over volume is, what do you call that? Density. Good job. DRT. So that means P mm over RT gives you D. You can find out the density of the gas. You can find out molar mass of the gas, having the identity of the gas, and you can find out the density also. So that's how it is very important when it comes to the gas. But make sure know the R value is liter atmospheres, and everything has to be converted to the liter atmospheres if you are given in torr or the milliliters or the mass in gram. Okay. Now go over. I have to stop here, but let me mention a couple of things. Dalton's law of partial pressures is like this. We say other day, okay, here is a 0.97 atmospheres. Air pressure. Air is a mixture of gases. So Dalton's law of partial pressure is total pressure equals to the pressure caused by individual gas in the container. If this room is a container, in the room. Okay. Go over that, find there are a few simple calculations based on the same thing. Graham's law of diffusion and effusion. Effusion means if you poke a small hole in your tire, that gas is effusion. Okay. If you mix up the 2 gallons of gas together, then there's the diffusion. Okay. Effusion means from a small aperture, and diffusion means mixing together in large volume. So there are one rules on that, one formula on that. Make sure you know that. It seems easy, but you have to realize certain things because it's invisible. Gas is invisible. You just realize it. It's not like a liquid and solid. Sometimes it's hard to convince yourself, but once you convince, things going to be easier. So again, you need to give more time. Okay, I'm going to stop here. So I'm going to give you your score on your lab. Okay. Make sure to take exam by Thursday. Do not write on the test because there is a penalty. There's a price penalty, not the point penalty. Okay. And the grade will be in eConnect by Monday. And prior to that, I'll put your total score on eCampus. Of course, it will be visible. You have all the exam scores, and I'm going to add your score from the lab today. Well, once you are done, hopefully today. Okay. Any questions? Let me know.